Hello there and welcome to Bedtime Science Channel. I am so glad you found your way here. Maybe you've had a day filled with earthbound concerns, or perhaps you are simply drawn to the quiet majesty that dances in the outer reaches of our solar system. Either way, tonight's journey is for you. You have nothing to do but rest. Let your mind drift like particles in a cosmic dance. Your breathing slow like the ancient rhythm of planetary motion, and your thoughts settle into the serene vastness of space. Because tonight, we're traveling to one of the most beautiful sights in our solar system. Saturn's rings, those magnificent bands of ice and rock that circle the golden giant in perfect harmony. We'll explore how countless fragments create breathtaking patterns, how shepherd moons guide wandering particles, and how light plays through these cosmic jewels to create the most elegant display in the heavens, from microscopic ice crystals to building-sized boulders, from ancient collisions to ongoing renewal. We'll discover a celestial symphony written in orbital mechanics. Some of what you hear tonight may change how you see the night sky. Other discoveries might simply flow around you like cosmic currents, gentle and quietly profound. If these peaceful explorations help you unwind or fill you with wonder as you drift towards sleep, consider liking and subscribing to the channel. It helps others find their way here too, one stargazing soul at a time. Now, let yourself float into comfort. Take a deep breath of cosmic wonder, and let's begin this gentle journey to Saturn's magnificent rings. Saturn's rings are made primarily of water ice, with particles ranging from tiny grains to massive chunks, the size of houses. These frozen fragments reflect sunlight brilliantly, creating the shimmering bands we observe from Earth. Each particle follows its own orbital path around Saturn, yet together they form one of the most organized and beautiful structures in the solar system. The rings are incredibly thin compared to their width, spanning hundreds of thousands of kilometers yet measuring only about 10 meters thick on average. If you could scale the rings down to the size of a compact disc, they would be thinner than tissue paper. This remarkable flatness results from countless gentle collisions that gradually flatten any vertical motion into a perfect plane. Galileo first observed Saturn's rings in 1610, though his primitive telescope made them appear as mysterious handles or arms attached to the planet. He described Saturn as having ears, unable to resolve the true nature of what he was seeing. It wasn't until 1659 that Christian Huygens correctly identified them as rings surrounding the planet, solving a cosmic mystery that had puzzled astronomers for decades. The rings are divided into several distinct sections, each with its own characteristics and orbital properties. The main rings are labeled A, B, and C, with the bright B ring being the most prominent and dense. Between these major divisions lie gaps and more subtle rings, creating a complex system that continues to reveal new details with each spacecraft visit. Shepherd moons are small satellites that help maintain the structure of certain rings through their gravitational influence. These cosmic gardeners orbit near ring edges, using their gentle gravitational pull to keep particles in line and prevent them from spreading out. Pan and Daphnis are two such moons that create waves and clear gaps in the rings through their careful orbital dance. The Cassini division is a prominent gap between the A and B rings, clearly visible through even modest telescopes from Earth. This 4,800-kilometer wide space appears empty from a distance, but spacecraft have revealed it contains its own faint ringlets and structures. The division is maintained by gravitational resonances with Saturn's moon Mimas, whose orbital period creates a cosmic rhythm that sweeps particles away. Ring particles are constantly colliding and breaking apart, creating an ongoing cycle of destruction and renewal. Large chunks gradually fragment into smaller pieces, while tiny grains sometimes stick together to form larger aggregates. This dynamic process means the rings are neither growing nor shrinking dramatically, but instead maintaining a delicate balance between creation and erosion. Saturn's rings may be relatively young in cosmic terms, perhaps only 10 to 100 million years old. This suggests they formed long after the planet itself, possibly from the breakup of a moon or large comet that wandered too close to Saturn. The ring's bright appearance and the presence of shepherd moons support this theory of relatively recent formation. The rings create their own weather systems, with temperatures varying across different sections and altitudes. Areas dense with particles stay cooler as they block sunlight, while gaps and thinner regions can be significantly warmer. These temperature differences drive gentle currents and flows within the ring system, creating a kind of cosmic meteorology. Spokes are mysterious, temporary features that appear like dark radial streaks across the rings, particularly in the B-ring. These ghostly formations can stretch thousands of kilometers and persist for hours before fading away. Scientists believe they're caused by electromagnetic forces that briefly lift tiny particles above the main ring plane, creating these ethereal patterns. The F-ring is one of the most dynamic and changing structures in Saturn's ring system. Twisted into braids and kinked by gravitational interactions with nearby shepherd moons, this narrow ring constantly changes its appearance. Prometheus and Pandora, two small moons flanking the F-ring, stretch and compress it through their gravitational dance. Saturn's magnetic field interacts with charged particles in the rings, creating complex electromagnetic phenomena. This interaction helps explain some of the unusual structures observed, including the mysterious spokes and the way fine particles behave differently from larger chunks. The planet's magnetosphere essentially extends its influence into the ring system itself. The rings cast shadows on Saturn's surface, creating beautiful patterns that change with the planet's seasons. As Saturn orbits the Sunday over its 29.5-year period, the angle of sunlight on the rings changes dramatically, sometimes making them appear to nearly disappear when viewed edge on from Earth. These seasonal changes reveal different aspects of ring structure and composition. Each ring particle is essentially a tiny moon of Saturn. Following the ring system contains billions upon billions of individual particles, each following its own unique orbit around Saturn. Despite this seemingly chaotic situation, the collective behavior of these particles creates remarkably stable and long-lasting structures through the emergent properties of gravitational dynamics and particle interactions. Saturn's rings have inspired countless works of art, literature, and music throughout human history. From the first telescopic observations to modern spacecraft images, these celestial bands have captured the imagination and wonder of generations. They represent both the beauty and the underlying mathematical elegance of celestial mechanics. The discovery of propeller-shaped structures in the A-ring reveal the presence of unseen moonlets that create gaps and wakes in the surrounding ring material. These cosmic propellers, each about 100 kilometers long, demonstrate how even small gravitational perturbations can create large-scale structures in the delicate environment of the rings. Ring particles undergo constant weathering from micrometeoroid impacts, radiation, and plasma bombardment. This space weathering gradually darkens and contaminates the pristine ice, explaining why some regions of the rings appear darker than others. The process also contributes to the ongoing evolution and aging of the ring system. The ring's gravitational influence extends far beyond their visible boundaries, affecting the orbits of nearby moons and creating complex resonance patterns throughout Saturn's satellite system. These gravitational relationships help maintain the long-term stability of both the rings and the moon system, creating a delicate balance that has persisted for millions of years. Plasma interactions between the rings and Saturn's magnetosphere create unique chemical processes not found elsewhere in the solar system. Charged particles trapped in Saturn's magnetic field bombard ring material, potentially creating exotic chemical compounds and contributing to the erosion and evolution of ring particles over time. The transparency of the rings varies dramatically from region to region, with some areas nearly opaque, while others allow clear views of Saturn's surface beneath. This variation reflects differences in particle density, size distribution, and composition, creating a complex mosaic of optical properties across the ring system. Saturn's rings serve as a natural laboratory for understanding accretion processes that were important in the early formation of the solar system. By studying how ring particles interact, clump together, and break apart, scientists gain insights into how planets, moons, and asteroid belts formed billions of years ago from similar disk structures. The vertical structure of the rings is maintained by a delicate balance between gravitational forces that try to flatten the system and various perturbations that introduce slight tilts and warps. This three-dimensional architecture, though extremely thin, contains important information about the physical properties and history of ring particles. Color variations across the rings reveal differences in composition and particle size, with redder regions generally containing more contaminating material mixed with the dominant water ice. These subtle color differences are best revealed in enhanced images that stretch the contrast to show variations invisible to the human eye. The rings create their own acoustic environment through the constant low-level collisions between particles. While sound cannot travel through the vacuum of space, the vibrational energy from these impacts propagates through the ring material itself, creating a kind of seismic activity within the cosmic structure. Saturn's ring system influences the planet's upper atmosphere through the rain of charged particles that spiral down along magnetic field lines. This ring rain contributes material to Saturn's atmosphere and may affect atmospheric chemistry and dynamics in ways that scientists are still working to understand. The mathematical beauty of the rings reflects the underlying harmony of celestial mechanics, where simple physical laws governing gravity and motion combine to create structures of breathtaking complexity and elegance. Each particle obeys the same basic rules, yet their collective behavior produces patterns that rival the finest human artistry. Electromagnetic forces play an increasingly important role in ring dynamics as particle sizes decrease. While gravity dominates the motion of larger chunks, electromagnetic effects become significant for tiny grains, helping to explain some of the more unusual and dynamic features observed in the ring system. The study of Saturn's rings has revolutionized our understanding of disk dynamics throughout the universe. From protoplanetary disks where planets form to the accretion disks around black holes, the rings provide a nearby detailed example of how particles behave in rotating gravitational systems. Saturn's rings cast shadows, not only on the planet but also on each other, creating complex lighting conditions that vary with viewing angle and solar illumination. These shadow effects contribute to the three-dimensional appearance of ring structures and help scientists determine the vertical extent and thickness of different ring components. The longevity of Saturn's rings depends on a delicate balance between various forces that would normally cause them to spread out and dissipate over time. Understanding this balance is crucial for determining whether the rings are a permanent feature of Saturn or a temporary phenomenon in the planet's history. Tidal forces from Saturn's gravity are responsible for keeping the rings confined to their current location and preventing them from either falling into the planet or escaping into space. These same forces would tear apart any substantial moon that approached too closely, potentially creating new ring material through tidal disruption. The discovery of organic compounds in the rings suggests they may play a role in the complex chemistry of Saturn's system. While these materials make up only a small fraction of ring composition, they represent important clues about the source and evolution of the ring material over time. Saturn's rings demonstrate the principle of self-organization in nature, where simple interactions between individual particles give rise to complex, large-scale structures. This emergent behavior illustrates how order can spontaneously. Gravitational instabilities within the rings can create temporary spiral arms and other transient features that form and dissipate over time scales ranging from hours to years. These instabilities demonstrate how gravitational systems can exhibit complex, time-variable behavior, even when the underlying forces are completely predictable. The preservation of fine-scale structure in the rings requires ongoing energy input to counteract the natural tendency toward equilibrium and uniformity. This energy comes from various sources, including tidal interactions, electromagnetic forces, and the gravitational influence of nearby moons. Saturn's rings serve as a cosmic timekeeper, with their orbital periods and structural changes providing clues about the evolution of the entire Saturn system over geological time. The rings essentially act as a detailed record of the gravitational and physical processes that have shaped the planet's environment. The study of ring dynamics has practical applications for understanding other astrophysical systems, from galaxy formation to the behavior of planetary debris disks around other stars. The rings provide a laboratory where theories can be tested against detailed observations. Each spacecraft mission to Saturn has revealed new complexities and unexpected features in the ring system, demonstrating that these structures are far more dynamic and intricate than early observations suggested. The rings continue to surprise scientists with their richness and variety. The gravitational influence of the rings extends throughout Saturn's magnetosphere, affecting the motion of charged particles and the structure of the planet's magnetic field. This coupling between ring material and electromagnetic phenomena creates a unique environment found nowhere else in the solar system. The rings' role in Saturn's energy balance is subtle but significant, as they both absorb and reflect solar radiation while also radiating heat back into space. These thermal effects influence atmospheric circulation patterns and contribute to the planet's overall climate system. Saturn's rings represent one of the most successful examples of celestial mechanics in action, where the precise mathematical descriptions developed centuries ago continue to accurately predict the motion and behavior of trillions of particles in a complex gravitational environment. The discovery of water ice geysers on Saturn's moon Enceladus has raised questions about possible connections between the satellite system and ring material, suggesting that the boundary between moons and rings may be more fluid than previously thought. The rings demonstrate the importance of collective phenomena in physics, where the behavior of the system as a whole emerges from the interactions of its individual components. This principle appears throughout nature, from flocking birds to galaxy formation. Seasonal changes in the rings occur over Saturn's 29.5-year orbital period, with different ring regions experiencing varying amounts of solar heating as the planet's tilt changes its orientation relative to the Sunday. These long-term cycles affect ring particle properties and behavior. The mathematical modeling of ring dynamics requires sophisticated computer simulations that track the interactions of millions of particles over long time periods. These computational challenges have driven advances in numerical methods and our understanding of complex dynamical systems. Saturn's rings have become an icon of our solar system, representing both the beauty and the underlying order that characterizes planetary systems throughout the universe. They remind us that even in the apparent emptiness of space, magnificent structures can arise from simple physical principles. The ongoing evolution of the rings means that their current appearance represents just one moment in a long history of change and development. Understanding this evolution helps scientists piece together the story of how the Saturn system formed and how it will continue to change in the future. The rings create a unique acoustic environment through particle collisions and electromagnetic interactions, generating radio emissions that have been detected by spacecraft. These sounds provide another way to study ring properties and dynamics beyond visible light observations. The delicate balance that maintains Saturn's rings illustrates the fine-tuned nature of many astronomical systems, where small changes in conditions can lead to dramatically different outcomes. This sensitivity makes the rings both beautiful and fragile on cosmic timescales. The study of Saturn's rings has contributed to our understanding of how disk-shaped structures form and evolve throughout the universe, from the primordial disk that formed our solar system to the accretion disks that surround forming stars and actively feeding black holes. The rings serve as a natural example of emergence in physics, demonstrating how complex, organized structures can spontaneously arise from the collective behavior of simple components following basic physical laws. This principle appears throughout nature at many different scales. Saturn's rings will continue to evolve and change over millions of years, potentially developing new features while losing others. Their future depends on the continuing interplay between the various forces that currently shape them, making their long-term evolution a subject of ongoing scientific interest and speculation. The magnificence of Saturn's rings lies not just in their visual beauty, but in the elegant physics that governs their existence. They represent a perfect marriage of mathematical precision and natural artistry, where the fundamental forces of gravity and electromagnetism collaborate to create structures of breathtaking complexity and grace. And now, as we drift back from our cosmic journey to Saturn's majestic rings, let these celestial wonders settle gently in your mind, like ice crystals floating in the vast emptiness between worlds. We've traveled through bands of dancing particles, where countless fragments create symphonies of motion, where shepherd moons tend their cosmic flocks, and where the fundamental forces of nature write poetry in orbital mechanics. You've witnessed the delicate balance that maintains these rings across millions of years, the way tiny particles organize themselves into magnificent structures, and the eternal dance between creation and renewal that keeps these cosmic jewels shining in the darkness. These rings exist right now, orbiting their golden giant in the outer solar system, catching sunlight and casting shadows in patterns too beautiful for words. Tonight, as you settle into sleep, remember that you are part of the same universe that created Saturn's rings. The same physical laws that guide ice particles in their graceful orbits also govern the gentle rhythm of your breathing. The same forces that maintain cosmic harmony also keep your heart beating in its steady pattern. So let your thoughts become like ring particles, settling into peaceful, stable orbits around the calm center of rest. Let your breathing flow like the ancient rhythms of planetary motion, and let yourself drift into the deep, restorative sleep that comes from knowing you belong to a cosmos of infinite beauty and mathematical elegance. If you happen to still be awake, you can continue exploring the wonders of our solar system. And if these ring discoveries have helped you find peace among the stars, consider subscribing to journey further into the quiet majesty of science. One celestial breath at a time. Good night, and dream of cosmic rings dancing in the darkness.